In today's lesson, we are learning about the real number system and the applications thereof. Looking at our number system consists of the following. The first branch is called the complex numbers. And on the other side, we are going to look at undefined numbers. Undefined simply means when we have terms that are divided by 0. For example, if I have 15 divided by 0 or 2 divided by 0. Even more complex terms like 3 pi plus 1 divided by 0. Let's test it on the calculator. If you press your fraction button, and you can put any number in for reference in the example, let's try 89, and you press over 0. Do you see it says math error? So this is what will come up whenever you're doing a division by 0. So these are all part of our undefined numbers. While on the other branch, our complex numbers make up a large part of the number system. So let's evaluate what falls under complex numbers. This can be broken up into real numbers, denoted by this R, as well as non-real numbers. This is denoted by R with a dash. Examples include the square root of a negative number. For example, the square root of negative 4. Now, we know the square root of 4 is 2, but no number times itself can yield negative 4. Try it out in the calculator. If we press the square root and input any negative number, it's also going to give us a math error. You can even try one like the fourth root of negative 7. So here you are going to press shift and then this button over here. Press 4 for the outer root value and then negative 7 once again. So whenever we have these even values here on the roots, we can never have a negative. Now, real number system. This one is a massive suitcase that contains little bags inside. So the real numbers can now be classified as rational, denoted with a Q, or irrational, denoted with Q dash. Examples of this can include numbers like 3.79134890001 and so on, carrying on forever. What we see here is there is no end and no pattern apparent in the decimals, right? Some more examples can include the famous pi. When we punch in pi, shift and you press this button here at the bottom, and then you convert it to a decimal. Do you see that? Actually, it continues much further than that. So pi is also considered irrational. A new word that you will learn in grade 10 is called a surd. So anything involving a root that's not a perfect square. For example, the square root of 5. There's no concrete number like 2 or 4 or something like that. It's going to give you this long string of decimals as part of the answer. So those are classified as irrational. While rational numbers are any numbers which can be expressed as a fraction. For example, negative 5 over 9, 1 over 2, or 0.375. Okay, now what's the difference between this decimal and this one? Can you see this one has an ending? This is called a terminating decimal. To terminate means to end. So it has an ending over there. Even if I look at the fraction 1 over 3, as a decimal it's 0.33333. We can also denote this as, I'm just going to do a slash here, 0.3 with a dot on top. This term is recurring. So we can have decimals if it's terminating or if it is recurring, then it's still classified as rational. From rational, we can move on to what's called an integer. Integers are denoted by this Z symbol. This includes anything on our number line, such as 0, our positives, which run 1, 2, 3, 4, 5, and so on in the positive direction, as well as including our negatives, -1, -2, and everything running in left towards the negative direction. Those are our integers. Included in our integers are what we call whole numbers or counting numbers. This is denoted by the symbol, this N with a little 0 at the bottom, subscript 0. And this is involving counting numbers which run from 0, 1, 2, and so on. So I always remember whole numbers, because of this N0, this O, it reminds us that we need to start counting from 0. And then the last little bag in this suitcase of the number system is known as our natural numbers. Natural numbers are denoted just by the N, and this is how we learned to count when we were children. They run from 1, 2, 3, and so on. So we have this really big picture of the number system and what falls under what types of headings. So we start with natural numbers, 1, 2, 3, proceeding to whole where we introduce 0, moving on to integers where we move along the positive and negative number line. All of these are classified under rational in addition to things like fractions, terminating and recurring decimals. Rational numbers are part of the real number system as well as our irrational numbers. Irrational are these ones that are not terminating and not recurring. Real number systems, as the real numbers as well as our non-real numbers, fall part of the complex numbers. And complex numbers are encapsulating all of what we've just discussed. And then the complex numbers fall under the big heading called number systems, which also include our undefined numbers. So here is a nice summary of all of the number systems and all the examples. I'll also include one here if you'd like to take a screenshot. This one is appropriate for grade 9s, grade 10s, and up. This one is for grade 10s and up. Let's have a look at a few basic examples. 0.1. This is part of our number system. This is what we call a real number. Within the real, we can see it's rational as well. Why rational? Because this is a terminating decimal. So it's rational. It's not going to be classified as an integer because integers are our negatives, 0 and positives. So if it's not an integer, it won't be whole and it won't be natural. 217. This is a fraction, so it is real. Anything that can be expressed as a fraction is also rational. However, it's not an integer because it doesn't fall -1, -2, -3, etc. So this is the only classification here. The square root of -9 plus the square root of -2. But notice here, the square root of a negative, that is a problem. It's part of the non-real numbers. Just as a reference, remember, non-real is the root of a negative. So this is non-real. And there's no further classification that you guys need to know for now. This one here, 1,527,354, and so on. This implies that it's continuing. It is, of course, a real number, but it's not rational because it doesn't terminate and it doesn't recur. So this is classified as an irrational number. -4, and then of the fraction 3/11. This mixed number, of course, it is real. It is rational because it can be expressed as a fraction. However, it is not an integer, natural, or whole. There's -12. This is a real number. It is rational. And we can go into a further classification of integers because it works on the number line, which includes our negatives, 0, and positives. Now, you're probably wondering, what would a number like 2 be classified as? 2 is real. It's rational. It's part of our number line, so it's an integer. When we count using counting numbers, 0, 1, 2, okay, so it's a whole number. And then it's also part of our natural numbers, because when we start counting from 1, we're eventually going to get to 2. 1, 2. If you've enjoyed this video and you've learned something from it, you may want to check this one out next. A like and a subscribe will help us to grow our channel, and feel free to share this with any of your friends so we can all achieve academic success together. See you in the next one.